Hello, and welcome to a study of research and experimentation. This is a brief introduction to psychological research. So let's begin with our learning goals and objectives for this presentation. We're going to define goals for conducting research, explain the scientific method. We're going to describe various research collection methods. How do you interpret research results? Discuss experimental bias and what that means. Describe psychological tests and discuss ethical considerations in research. So, what are the purposes of research? Psychologists have three main goals when doing research. One, to find ways to measure and describe behavior, to understand why, when, and how events occur, to apply this knowledge to solving real world problems. Psychologists use the scientific method to conduct their research. And as we've studied in other units, the scientific method is a standardized way of making observations, gathering data, forming theories, testing predictions, and interpreting results. And we're going to look at the scientific method in more depth. So, researchers make observations in order to describe and measure behavior. Then, we form a theory which explains these observations. And you already know that a theory is simply an explanation that organizes separate pieces of information in a logical way. It allows researchers to come up with a clear prediction how to check that theory. Once that theory is formed, then he can make a hypothesis, which is a form to test the theory. We call it an educated guess. And by stating a hypothesis, a prediction of what will happen given a certain set of conditions. And this is where we conduct our experiment, collect our data to test that hypothesis. And once we have collected our data and tested the hypothesis, we can decide whether the hypothesis was correct. And if it was correct, we can do more experimentations. And if it was incorrect, we can come up and form a new hypothesis. And we can come up with new theories. And once we conduct that experiment, gather our data, then we can form a conclusion and draw, which is drawn to prove or disprove that hypothesis. More about the scientific method. Psychological research must meet certain criteria in order to be considered scientific. It must be replicable. It is replicable when others can repeat it and get the same results with the same group of subjects, but at a different time and under the same conditions. It also must be falsifiable. It must be stated in a way that makes it possible to reject it. We have to be able to prove a theory or a hypothesis wrong. And then it also must be precise. Psychologists ensure that they can replicate their own and others' research. To make hypotheses more precise, psychologists use what we call operational definitions, which states exactly how a variable will be measured. And we will talk about variables in a few minutes. So, what are the steps to the scientific method in a brief summary? First step, we ask a research question. Then we state a hypothesis. After forming a theory, we conduct an experiment where we gather our data to test our hypotheses. Then we analyze the results, and then from the results, we can draw a conclusion about our hypotheses. There are various research collection methods, and one method is the case study. And a case study provides uh, studies where we can study individuals or we study small groups, and it's a good way to generate a hypothesis. However, it can be very subjective and it may yield biased results because subjects will not always answer honestly or give you the information you're looking for. And it doesn't allow conclusions about a cause and effect relationship. That is the case study method. Then we have we do descriptive research where we use surveys. And researchers can describe events or experiences or behaviors and look for a direct link between them. But these methods do not enable researchers to determine cause of behaviors. We've already talked about case studies and we talk about surveys, and there are various different kinds of surveys which we can get a lot of information and can also form a hypothesis. And it can provide information about many people because it's cheap and it's easy to do. That is the survey method. Then we can also collect information and study behavior by doing a naturalistic observation. And this is where researchers study subjects or individuals in their natural environment or their natural habitat if they are studying animals. But it does not allow conclusions about cause and effect relationships. And it can to sometimes yield a biased result. And it carries a risk of observed behavior that is different from the natural behavior. When people know that they are being observed, then their behavior is going to really change. They're not going to behave as they naturally would if they didn't know that they were being observed. And of course, they can use uh, collect data by using sophisticated equipment such as cameras, video cameras. Then sometimes we do laboratory observation where we study individuals in a laboratory or group uh, or a group survey or group participation where we measure and record their behavior and then we observe how they behave in certain situations. It can also be used for generating a hypothesis, but observations, laboratory, doesn't always allow conclusions about cause and effect relationships either. And it also requires good reliability and validity before it can be used. Reliability means that can it be duplicated? Can we get the same results if we observe the same group of individuals under the same situations? And the validity, does it measure what it is intended to measure? And of course, we use psychometric tests, which gives information about characteristics such as personality traits, emotional states, aptitudes, interests, abilities, and behaviors. And it also requires good reliability and validity before it can be used. But it doesn't allow conclusions about cause and effect relationships either. And we're all familiar with the IQ test. Various different types of personality tests. The aptitude test, which measures skills and abilities. And then there's psychiatric scales. And of course, direct observation that we've just seen. And neuropsychological profiling. Now, when we talk about experiments, subjects have to be placed in various groups in order to be studied. So we have what is called random selection and random assignment. And random assignment is a procedure using experiments to create multiple study groups that include participants with similar characteristics so that the groups are equivalent or equal at the beginning of the study. Random assignment is also how you assign the sample that you draw to different groups or treatments in your study. Random selection is how you draw the sample of people for a study from a population. For example, in this diagram, you have a population of 12 subjects, and from this group of individuals, you want to take a small sample because you can't survey or sample every individual in a population. And so, here with the random selection, they are selecting every third subject. Start with they are assigned numbers. So they start with two, and then the next third one, the next third one, and the next third one. And they keep on until they get a representative sample of the entire population. That is random selection and random assignment. And we'll see how this works in a real situation. Variables or events, characteristics, behaviors, or conditions that researchers measure and study. A subject or participant is an individual or person or an animal that the researcher studies. And the sample that we've just seen is a collection of subjects researchers study. Researchers use samples because they cannot study the entire population, as we've just demonstrated. And the population is a collection of people or animals from which researchers draw a sample. Researchers study the sample and generalize their results to the entire population. And so now we talk about various variables. An independent variable in an experiment, the subjects are divided into an experimental group and a control group. The subjects in both groups receive the same treatment. The researcher manipulates one part of the treatment in the experimental group but does not manipulate it in the control group. The variable that is manipulated is the independent variable. The researcher can compare the experimental group to find out whether the manipulation of the independent variable affected the dependent variable. And in the next slide, we'll see an illustration of that. In the experiment, which is another type of research that we do, they identify cause and effect relationship in experiments. We can determine whether one variable causes another. We can distinguish between a placebo effect and a real effect of a treatment or a drug. And then we can compare experimental group with the non-experimental group, which is the control group. And the dependent variable is the observed effect of the treatment, the placebo or the real drug. And of course, in the dependent variable, it's the outcome that the researcher is seeking. And in this illustration, you can see you have two groups in random assignment. One is in the participation group, and the other replaced in the comparison group, the which is the control group, and the participant group is the experimental group. The experimental or participant group, they're given a pretest, then they're placed in the program, and then they're given a post-test. But the comparison group, they're also given a pretest, and they receive no treatment. They're not placed in a program, and they are given a post-test. Then we can compare the comparison group with the participant group to see if the effects are any different. So once we have gotten our results, we need to interpret this data to see what it means. And researchers do this by using descriptive statistics, which is used to organize and summarize data. Researchers use numbers to describe what happened, and this is considered descriptive statistics. Researchers may use histograms or bar graphs to show the way data are distributed, And this makes it easier to compare results, see trends in data, and evaluate results quickly. As we illustrate in this diagram, you have three different courses, groups, and study times, and they compare to see whether there is a difference in the way students study, which we'll describe in a few minutes. And what we have just described will lend itself to inferential statistics. After analyzing statistics, researchers make inferences or we can draw conclusions or make predictions about how reliable and how significant the data are. An example here using this same group, the researchers' survey of the students in three classes showed differences in how long the students study for each course. The mean number or the average number of hours for students in course A was about 8 hours, and for students in course B and C, it was about 6 hours. But does this mean that the course A requires the most hours of study, or were the differences the researcher observed in study time real, or was it just due to chance? In other words, can he make a generalization from the samples of students he surveyed to the whole population of students? And he needs to determine the reliability and significance of his statistics. Is this a reliable study? And how do we do this? We would have to duplicate it with the same group of students at a different time and under the same conditions. Then we also interpret results using measures of central tendency. And researchers summarize data by calculating the mean, the median, and the mode. And the most commonly used measure of central tendency is the mean, which is the arithmetic average of the scores. And it is calculated by adding up all the scores and dividing it by the number of scores. The mode is the most common value in the distribution, the number that occurs the most in a typical distribution of scores. And the median is the middle score. The mean, however, we know is not a good summary method to use when the data include a few extremely high or low scores because scores surrounding the mean can either skew the distribution left or skew the distribution to the right. So it is not really a very significant figure to use. Then we have measures of variability. This tells researchers how much the scores in a distribution differ. Examples of measures of variation include the range and the standard deviation. Now, the standard deviation provides more information about the amount of variation in the scores. It tells the researcher the degree to which scores vary around the mean of the data. And of course, in this type example, you see the mean score here. And it says the mean is about the same as others in the center of the distribution, but here is probably less than others if the scores are extreme, or more than others on the other side of the mean. And here in the bottom graphic, you see the average mean here. So those are here are above average, well above average, but most of them fall in this range between 68%, the 16th percentile, and 84th percentile. Here on this side of the mean, they're well above average, and below the mean, they are well below average if they fall below in the 16th percentile. The range is the difference between the highest scores and lowest scores in the distribution. Here, the lowest score is 12, the highest score is 62, and you have a difference of 50. So the range of scores fall between 12 and 62, or 50 and 62. Now, we said that we can predict behavior, and we can predict behavior by using correlations. Correlation is a statistical measure that indicates the extent to which two or more variables fluctuate together. A positive correlation indicates the extent to which those variables increase or decrease in parallel. A negative correlation indicates the extent to which one variable increases as the other decreases. Now, correlation is not the same as causation. Two factors may be related without one causing the other to occur. Then there is a third factor called a confounding variable that can explain the correlation. And in this illustration, we have what is called a correlation coefficient, which measures the strength of a correlation, which is the number. Positive correlation means that there, as one variable increases, the other one does too. Here, the number of hours studied are definitely correlated or related to a certain grade being earned, but hours studied does not necessarily mean that it caused a higher grade. R equals 0.89. The closer the number is to 1.00, the stronger the correlation, as we'll explain in the next slide. A negative correlation is a relationship between two variables such that as the value of one variable increases, the other one decreases. The higher the correlation coefficient, the stronger the correlation. A positive zero point 0.9 or a negative zero point 0.9 indicates a very strong correlation. A positive point 0.1 or a negative zero point 0.1 indicates a very weak correlation. In this illustration, showing a negative correlation that the number of beers drank as they increase, the grades decrease. So that is a strong negative correlation, correlation coefficient of negative 1.00. And in the bottom graphic, you have a zero correlation. There is no relation that exhibits between the two variables. There is no correlation between shoe size and IQ. So this is a negative correlation as illustrated in the scatter plot. Now, we have what is called experimental bias. It's where the experimenter can control the outcome of the experiment by doing what is called single blind and double blind studies. And in a single blind study, patients don't know whether they are taking a treatment or a placebo controlled dosage forms. And in a double blind study, both patient and doctor are in the dark. They do not know which is which. Now, here in this example, why do heavy drinkers misreport their alcohol use? Well, in the biases here, we see the sample bias. Research participants don't reflect the larger population. We know that. The experimental bias, the researcher influences outcome in the expected direction that he wants it to go. The participant bias, experimental condition influences participants' behavior. Is when they know what they are taking. Social desirability, the participant provides dishonest answers to personal, risky, or embarrassing questions. And so the biases in the experiments can be controlled either by the experimenter or the researcher to get a desired result. Ethics in research is very, very important as a researcher There are certain things that we must do to protect the integrity of the research that we want to do. And it refers to a system of moral values or the way people distinguish right from wrong. The American Psychological Association, or APA, requires its members to adhere to its code of ethics, which applies to the treatment of both humans and animals. And here, before conducting psychological research, the code of ethics requires all researchers to follow certain guidelines. They must submit their proposal to an ethics committee so that they can study it and judge it according to safety and consideration for the participants in the study, especially when doing human subjects research. Here are common ethical guidelines that researchers must follow. They must protect the right and well being of participants and weigh against the study's value to science. The participants must be allowed to make an informed decision about whether they want to participate or not. Deception must be justified. Deception meaning that you reveal the true nature of the research and what the study is all about. Participants may withdraw from the study at any time and they must be informed of their ability and right to withdraw. Participants must be protected from risk or told explicitly of risk or any harm that may occur. Investigator must debrief participants, telling the true nature of the study and expectation of results. And the data must remain confidential as well as the participants in a research study. They must remain anonymous as well. When doing research with animals, there's also certain guidelines that you must follow. Although animals can't give consent, they can't talk, they can't sign papers, uh, it's very controversial with a lot of animal rights groups. And of course, some experiments require animals, so they must follow strict ethical guidelines, which are outlined in the Animal Welfare Act, the National Institute of Mental Health Methods and Welfare Considerations in behavior research with animals. And guidelines are the same with animals as well as with humans. They must obey the guidelines set forth by the American Psychological Association, the Ethical Principles of Psychology and Code of Conduct, also the Association for the Accreditation of Human Research Protection Programs. And studies within the US, Canada, and other countries must be approved by the Institutional Review Board, such as when you are conducting research with human subjects. So, this is just a brief overview of psychological research. And following this presentation, complete your 10 question multiple choice quiz.